Hi, welcome to the Olympiad geometry. Let's continue our study on the radical axis. Before we start, if you think this video is helpful, please click the like button, comment, share, or subscribe to the channel. Thank you. Circle O is tangent to L1 and L2. L1 is in parallel with L2. Circle O1 is tangent to L1 on point A and externally tangent to O on C. Circle O2 is tangent to L2 on B and externally tangent to circle O on D and externally tangent to circle O1 on E. AD intersects BC on point Q. Prove that Q is a circumcenter of triangle CDE. So before we learn about the solution of this problem, we need to just look at the case that we have two circles that tangent each other and tangent to a parallel line, to two parallel lines, right? So this is L1, this is L2. Let's still call this as circle O1 and call this as circle O2. This point is A, this point is E, this point is B. Let's dig of this figure a little more before we deal with this problem, right? So just look at the figure, you can have the feeling that AEB might be on the same line, right? These 3 points might be collinear. But how to prove that? We already know that O1A is perpendicular with L1 and O2B is perpendicular with L2. And we know that O1 and O2 are tangent on point E, right? We want to know that whether A, E, B are collinear or not. So things that we can do, and this would be a suggestion for the case that we see, simple tangent circles. We just draw the tangent line first, right? That usually would be very helpful. Just draw this tangent line here. Let's call this point as P, this point as Q, right? So let's connect O1E and connect O2E. Actually, we already know that because the circle O1 and circle O2 are tangent to each other on the point E. So we know that O1, E, O2 are collinear. And O1, O2 is perpendicular with the tangent line from point E, right? So this is 90 degree. This is 90 degree. This is 90 degree. So for here, we know that PAO1E is a cyclic quadrilateral. And if we do the connection of AE, right, and then we connect PO1, okay, what we get here that because AO1 equals to EO1, right? And PA equals to PE. PO1 equals to PO1. So we know that triangle AO1P is identical to triangle EO1P, right? Which means that angle APO1 equals to angle EPO1. Right, which is obvious because PA is tangent line, P is tangent line. Of course, that PO1 is angle bisector of angle APE, right? So we know that this angle, the angle PAE, the angle PAE equals to half of angle AO1E, right? So it equals to angle AO1P, right? This one equals to this, which means AE is perpendicular with PO1, right? This is 90 degrees. And similarly, we can prove that BE is perpendicular with QO2, right? So this is 90 degrees. And because L1 is in parallel with L2, right? L1 is in parallel with L2. So we know that angle APE equals to angle BQE, right? APE equals to BQE, which means the angle BEQ equals to 90 degrees minus half of angle BQE equals to 90 degrees minus half of angle APE equals to angle PAE equals to angle PEA, right? PAE equals to PEA. So PEA, this one, equals to angle BEQ. So we know that BEA are collinear, right? So we got BEA are collinear. Okay, based on this, now we look at this figure. Let's put the name of these points, the tangent point on, let's set it to be MN here. L1, L2 are the parallel lines, and O1 is tangent to L1, O2 is tangent to L2, O1, O2 are tangent at point E, so we know that AEB are collinear, right? Let's directly connect it. And look at the circle O and circle O1, right? Circle O is tangent to L2, circle O1 is tangent to A, and circle O1 and O are tangent at point C, which means ACN are collinear. Right? ACN are collinear, and AEB are collinear. So let's connect to the CE. What am I looking for, you may ask? Because we want to prove that AD, the intersection point of ADBC, the point Q, is a circumcenter of the triangle CDE, right? So we need to prove that CQ equals to QD equals to QE, right? So I'm trying to, if you just look at the figure, you have the feeling that CB might be the radical axis of the circle O and circle O1. AD might be the radical axis of circle O and circle O2, right? So I'm trying to prove that. So that's why I notice AEB are collinear and ACN are collinear. So we want to see that AC times AN is the power of A to the circle O, right? Power of A to circle O. And AE times AB is power of A to circle O2, right? I want to prove that AC times AN equals to AE times AB. In that case, if it's true, that means A is on the radical axis of circle O and circle O2, right? And we already know that circle O and circle O2 are tangent on point D, which means if we do a tangent line, right, we do a common tangent line of circle O and circle O2, it passes through point A, right? Because that's the radical axis of circle O and circle O2. So let's see, we want to prove that AC times AN equals to AE times AB. That means we already know that angle NAB equals to angle EAC, right? That means we just need to prove the triangle ACE is similar to triangle ABN, which means we just need to prove the angle AEC equals to angle ANB, right? And this is very easy because angle ANB equals to angle MAN. This angle equals to this angle, right? MAN. And we already know that MA is a tangent line of the circle O1. So angle MAN, which is angle MAC, equals to angle AEC, right? So we know that triangle ACE is similar to triangle ABN, which means AC divided by AB equals to AE divided by AN, which means ACAN equals to AEAB. Right, and this means that A is on radical axis of circle O and circle O2. This is important, right? Because based on this, we can do the similar thing, just prove that B is also on the radical axis of circle O and circle O1. I just cut those proof, the steps of the proof, right? It doesn't, I don't have to do it again, right? The steps are the same, are very similar. So A is on the radical axis of this one, B is on the radical axis of circle O and circle O1, which means Q is a point of common tangent of circle O and circle O2, and common tangent of circle O and circle O1, right? That means the distance from Q to the tangent point C equals to Q from the common tangent point D, right? So we know that QC equals to QD equals to QE, which means Q is the circumcenter of triangle CDE. Right, I think this is very straightforward, right? Because we already know that C is a tangent point and CB is a tangent line, D is a tangent point and DA is a tangent line, which means the intersection point Q that makes the QCQD to be the tangent line, so QC equals to QD, and similar to for the QE, right? Okay, so this problem is not a very easy one. I would say it's on the medium to difficult side, right? The difficult part is that we figure out A, E, B are collinear. This is a critical part. Once you get this one, and you can find that A, E, B is collinear, so you A, E, B are collinear, so you want to connect them. A, C, N are collinear, you want to connect them, and then it becomes very obvious that you want to prove AC times AN equals to AE times AB, so that A would be on the radical axis of circle O and circle O2, right? Okay, that's it. I hope you like this video. See you in next one. Thank you.